Hello guys, welcome back. Today we are going to understand some matrix based DB questions, right? Dynamic programming, in which the first question we have is 62 unique path for the DP question, right? So I'll put some series of questions, right, into this playlist. I will create one playlist in the our expert funder channel, right, on the YouTube, and you will go through all the videos so that you will understand the matrix style, right? What are the questions will come on the matrix style on DP. Okay, so it will help you to understand the dynamic programming questions. Okay, so please watch all the videos that I'm going to put into this playlist. Okay, or you can find directly onto the expert funder YouTube channel, and I'll give the name matrix style DP as a channel playlist name. Okay, so let's understand what is the question is saying. The question is 62 unique paths, right? So there is a robot on M cross N matrix, and robot is initially located at the top left corner. As you can see, this is left side and this is on the top left corner. That is called grid. This is grid at 0 and 0. Okay. And the next line saying that the robot tries to move to the bottom right corner, that is here he is going to finish his move, and that is called this location as a grid, or you can say cell at m-1 and n-1. Okay, so this is the grid we have. Right now robot can move only either you can say downside route and either right side. Okay, if there is a robot, right, so he can move downside, right, or either right at any point in time. Okay, whole on the whole grid, right, in any cells he is there, so he can move either downside or either right side. Now question is saying that we have given two integers n and m. Okay, m and n, and we have to return the number of possible unique paths, right? We have to find what number of possible unique paths that the robot can take to reach, right, the bottom to right corner, right? So how many paths can be possible unique path? Like he can come like this, right, he can come like this, he will come down, then he can come like this, right, or he can go like this. So there is many possible path will be there, right? So we'll understand how we are going to generate that. Okay, now the test cases is generated so that the answer will be less than 2 to the power 2 into 10 to the power 9. Okay, should be less than or equal to, that we will see in later. Okay, so let's understand how we are going to find this type of questions, right? So why this question is coming in the DP, as you can see, right? So if someone is starting from here, right, and he is going to count, right, either from here, let me clean this one. Okay, so if he is here, so from here either he will come this way, right, or either he will come this way, right? So there will be some value, right? Let's suppose, so if he is coming to here, right, and here, so there will be m we have given and n we have given, correct? So either he will come this side or this side, that depends on who the grid, right, that we will understand. So let's understand, since the robot can move either downside or right side, right, so there is only one path to reach the cell in the first row, that is this, right, from right, and he will go to the right. Okay, so there is only one path to reach the cell in the first row, that is right, and right. Now the same valid first column have the path that is down, right? Either he will go like this or the downside, right, as I told you. Okay, so there is only one path that is to reach the cell in the first column, and the first column from right, and down. Okay, now what about the inner cell m and n? To such cell, one could move either from the cell on the left, right, m and n-1, right, and for the cell above m-1 and n. That means that the total path to move into cell is m into m comma n cells is, that will come from where? It will come from m-1 n and m n-1, right? That will call you can say the number of path, right? So total number of path to move into this cell will come from this one plus this one, right? We have to do. Got it? Either we'll go this way or we can go this way. Let's suppose for if we are giving this m and this n, right? So m minus 1 means this is 0, right? And this is remains mn. And if we are putting m1, right? So n is n minus 1, right? So it will become like this. Okay, so for 1 1 means for this value, right, we will use what? Unique path 0 1 and unique path 1 0, right? So unique path 0 1 will come from where? Here. And unique path 1 0 will come from what? Here. So which one is max? It doesn't matter, because we are calculating the path, right? So there is two path that we are going to get here, right? And from here we'll move further. Okay, and we are storing the value here. Now this is a idea into three linear recursive solution, right? So we are passing what? M and n, means row and column we are passing, and we are generating the unique paths, right? So if this is m equal to 1 and n equal to 1, so we will return what? Minimum path is 1. Why? Because see, if we have a grid, right, and that m is only 1, right, and let's see our n is like this, okay, means one row we have, right, and column is multiples we have, right? In that scenario there is only one path, right? This is the path. Okay, there is only one path. Either if there is m is like multiple we have, right, m, but n is only one, this one, right? So there will be only one path. Okay, and that's why this is the base condition. We are returning if m equal to 1 or n equal to 1, then we are returning what? 1 as a base case, right? And we know that to calculate this unique path of m and n, we will do -1, m minus 1 and n minus 1, right? The two things we do calculate and will return this. So you may recognize this as a Fibonacci series also, right? So there will be some conditions, right? So we are calculating, or either you can say factorial things, right? So similar things we have here for the recursive solution, right? Because we are calculating from m and n. Okay, either we can move right side or downside, right? Two way. So in the right side, if is going, let's suppose, so there can be possibility m minus 1, right, and there is possibility n minus 1. Okay, but sometime it will, one of the things will remain same, right? So either n will remain same or m will remain same. Okay, that's why we will use m minus 1 comma n and m n minus 1. Okay, so but this solution is good, but most of the test cases will not pass, because this is recursive solution, and it will take if there is a big number, m is big number, n is big number, right? In that scenario, what will happen? Recursive call will getting called, and the stack memory will get full, right? So activation record will become full, and that scenario, it will give you the time complexity, right, error. Coming back to the approach one that you can use into the interview room, right? How we will find? So to calculate dp, you can say take a dp, right, or di11, and to calculate the dp, right, what we have to do? We will take 0 and 1 and 1 0, right? Either m minus 1 n, right, and m and comma n minus 1, and this is what we have, m and n, correct? So this is, if we put like this, so it will become dp at this and dp at this, right? Like this it will become plus dp at m and n minus 1, right? So this will come like this. Okay, so to calculate dp of m and n, we will do dp m minus 1 and n minus 1 like this. Okay, here and here you can see. So similarly, we are starting from here, right? And similarly we will calculate all these things like this we have calculated. So 2 will come. Similarly, if you are here, either you will go this way or you will come this way, right? So you will calculate this one, right? Similarly, it will come here, and we at the end we will calculate 28. So to calculate the 28, what we have to do? What m is here? 0 1 2 3 4 5 6. Okay, so m is here 6, right? And what is n? So 0 1 and 2, right? So this is 2. Okay, so to calculate this one, what we have to do, we will go to m will remain same, n minus 1, and m minus 1 n minus n, right? So we can calculate, it will come from here. Okay, if this is m and this is n, got it? So you can do like this. Now coming to the solution for this one, right? If this is m and this is n, we know that to calculate this one, what we have to do, we have to get the value, right? So first of all, we'll take a dp array, right? So dp array will be like this one that we have already seen, and we will calculate and we'll fill all the data here, right? So for that, we will take it here, and we will initially fill with 1 as a data, because initially we don't have anything, but this is 1. As you can see, initially we have 1 right? So we will fill all the data and we will calculate here, right? We will increase like this. So initially what we have 1 1 1 like this we will have. So we'll calculate this one and will come as a 2 as a value right here. So this is done. Now what will happen, we'll start from the column 1 to m and row column in this and this. So dp m minus 1 and n, and this will be m and n minus 1, right? So to calculate, and this is our m and n. Okay, so you can find this m and n using this formula, and you can calculate m minus 1 n minus 1 at the last, whatever with the data we have, this value is called m minus 1 and n minus 1. Okay, so this will we will return this data, and this will give you the unique path. Okay, so it's very easy, right? First what we have to do, we have to create your dp array, right? And you will fill all the elements with the minus 1 you can take, no sorry, 1 will take, and to calculate the dp you will use m minus 1 n and m n minus 1, and we'll fill the data. We have already filled the data with 1, and you will calculate all the data, it will store there, right? So that in this case the time complexity will become n into m, because if row and column is there, so that will get calculated. We'll go through all the cells, right? And we are storing in all the cell, right, data. So time complexity will remain same, and the space complexity. Okay, in the next part of this video we are going to see the minimum path sum, and let's continue.